derivatives are crucial to Phys 111. But before we get there, there is an important concept that we need to cover with quite a lot of applications. That's all about limits. And to begin with, let's have a look at a few functions to get intuition about what a limit is and what it can be used for. Now, an important concept to think about before we define it mathematically is continuity. Now, in our lives, we're probably used to thinking about continuity of events and what we would call something which is not continuous. For example, if I'm standing here, right, with a pen in my hand, and all of a sudden I now have a ukulele in my hand, this is quite a discontinuous sort of event. I mean, something just happened before this pen transformed into a ukulele. And we can also reverse this. So say that this ukulele is in my left hand. Now suddenly it is on my right hand. Something happened in between and we don't know what it is. But let's get rid of this. So to think about what continuity means in maths, it's quite useful to have a look at a few functions. So you can find this in the lecture notes. This is section 3 and 3.1. This is where we start talking about functions, values of functions, and the concept of limit. So I'll try to put down on the board similar functions. Now, if we take these three different functions, that's f of x, we call this g of x, and this one is h of x, so it is consistent with the lecture notes. It is important to have a look at these two different points, x equals a and x equals b. Now in function f of x, it's something not that weird. If you look at the function at these points, it is well defined, and it means you could read off the y-axis. In this case, it means that the value that the function tends to when we approach x equals a is basically the value of the function, and the same thing goes for x equals b. Now for g of x, this is not the case. So there's two different things that are happening at x equals a and x equals b. At x equals a, if we look at the value that the function approaches when it goes to x equals a, you would read it as here. Let's say that this is 1. But if you want to calculate the value of the function at x equals a, this is the actual value. So this means that the value that the function tends to is not the same as the value of the function at that point. And we'll see that this means this point is not continuous. Now, the point x equals b is even more complicated because when you look at it in the vicinity, if you approach point x equals b from the left, it actually tends to this value. But if you go from the right, it actually approaches this value. It is very weird as well because the function is actually not defined at x equals b. So this means, in this case, we don't have a value for the function at that point, and also, as we shall see, the limit also does not exist because there isn't a single number that the function tends to when we approach it from different directions. And of course, h of x is the more complicated case out of these three functions at these specific points. And that is because at x equals a, h of x is not defined there's an asymptote on one side and the other. And also, to make things complicated, the limit, or the value that the function tends to from the right, is actually minus infinity, and from the left it's plus infinity. So the function is actually tending to two completely different extreme values. The limit, as we'll see, also does not exist in this case. And finally, for x equals b, the function is also not defined at this point. It does tend to a real value from the left, but from the right it actually goes to plus infinity. So the limit also does not exist. So I would encourage you to have a look at the lecture notes and also make sure that you're familiar with the convention that we use filled points to mean the value of the point of that function, open circles when the function is actually not defined at that specific point, and if it is at other point, we fill it in like this, and also the notation for asymptotes that we will probably be using a lot for physics 111.